Hello, my fellow Almontians, and welcome back to another broadcast from the bunker on this windy Thursday, I believe. Anyways, I wanted to go over the Tic Tac Toe review before I issued you your little assessment on this unit. Got a lot of submissions. Some of you guys had some questions. Hopefully I can address all that. All right, let's start out with the do now questions on the top. Which graph best represents the correct relationship between discharge? Remember, discharge is the amount of water in the river and the particle size. Well, the more water in the river, the faster it goes, the more energy it has, so the bigger particle can be moved. So the graph we're talking about here, if discharge increases, you can erode bigger things. So you got to go with choice 2. All right. The second one, points A, B, and C are along the coast. Which line best represents the primary process occurring along this? Well, it looks like you have sand being transported. Well, transporting sand is erosion. The sand came from the land, so it must have broken off from the land. It must have weathered off. And then the sand is also getting deposited in certain areas. So you have the whole situation there. You have the weathering, you have the erosion, and the deposition. You got to go with choice 2. Okay. All right. So on this, it was classic tic-tac-toe. You had to either get diagonal, horizontal, vertical, etc. Whichever ones you picked, it had to go in that line. All right, I'm going to go through them all. And you should know how to do them all, but to get credit for the assignment, you had to have 3 of them done perfectly. All right? All right, that being said, let's roll right into it. Tic-tac-toe. We'll start with the central box. Everybody had to hit the central box. Explain why the upper valley in the mountain is U-shaped and the lower is V-shaped. Well, the upper, if you see here, the classic U-shape, you totally see it there. And that's because glaciers carve out U-shapes. And up in the mountains, it's colder. You have your snow and your ice. You're going to get that U-shaped valley. Yosemite Valley, if you ever head out to California, is a classic U-shape. But lower down in elevation, it gets warmer. The ice melts, and it flows like a river. And rivers cut with a V. So you'll get more of a V shape in here. All right, and I like writing it so that you can remember it, right? Glaciers. This is not the proper way to spell it. Right? Glacier with a U. And, of course, river with a big V. Okay? To help you remember the shapes. Identify which point X or Y has more stream erosion and explain why they're different. Well, if you remember, the curves in a river are called meanders. And if you're on the inside, the water goes slower. And if you're on the outside, it goes faster. So, faster water means more erosion. So at X, you'll get more erosion. And where it's going slower, you'll get more deposition. Right? So X equals more erosion because the water is going faster. On the outside curve. Okay. All right, obviously the opposite is true for Y. You'll have less erosion, more deposition, because that's on the inside of the meander. All right? Explain why stream meanders on the floodplain but not in the mountains. Well, if you're meandering, you're getting older. The river is slowing down. Up in the mountains, if you look at the picture, it's a much straighter shot. The water's going much faster. It's steeper. It doesn't have time to cut side to side into the rock. It's just cutting down. So you're going to get meanders in the valley because there's less relief, less change of elevation. The water is slowing down. And the straighter river higher up because it's steeper and it's just cutting straight down into the rock instead of curving. Okay? All right. Over here it says the beach consists of particles with these diameters, 0.01 to 0.1. Identify the sedimentary rock that will form if these got buried and cemented together. Well, I don't expect you to remember those ranges of numbers, but go to your reference tables, 0.01 to 0.1. Hopefully you remember which chart we're going to here. There it is. We'll zoom in for a second here. And 0.01 to 0.1 you could find on this chart, and that's in the sand realm. Or you can go to your sedimentary chart and find the same thing. 0.01 to 0.1 is within that realm there, the sand realm. So if it's sand being cemented together, what are we going to make? A sandstone. Okay. And I'll put SS for sandstone there, right? A ball was dropped from point X, traveled a distance of 20,000 centimeters. That's kind of a strange unit to have a number that big. They should have converted to meters, but whatever. To the end of the river at the delta, the travel time was 360 seconds. Determine the rate. Stop right there, folks. Rate. If you don't remember the formula, you know where to go. All the formulas on the front page of the tables right here. And there it is, rate of change. It says change in field value over distance, but in this problem, the change of field value looks like, well, let's see, what is it, elevation? Let's see what we have here. Change in value, excuse me, that was the gradient. I meant the rate one. Change in value over time. So let's go over here. The time is 360 seconds. The value is distance. So we're going to do 20,000 divided by 360. Right? 20,000 divided by 360. Break out your dollar store calculator. 20,000 divided by 360 gives you a whopping 55.5. Repeating, we'll round that to 56. And the units, of course, will be centimeters per second. It was looking for a rate. So it's about 56 centimeters per second. Okay? Okay. Then we get to our task A here. You have a aerial view of a river. It wants you to plot the profile. So that's the first thing I'll do. It gives you the data for point A to B in distance, and then it gives you depth of the water between those two. All right? Well, let's do it. It already plotted the x-axis, which I know looks strange at the top, but that's still the x-axis. And the y we got to plot, well, it looks like our range goes from 0 to 617. So if you skip by 2's, it should fit quite nicely. All right, we'll enlarge this for a second here, but I'm going to go down 18 all the way at the bottom, and that will cover all the numbers in the range. Okay, and now to plot it out, well, 0, 0 they already did for you. Go out to 10, you have a depth of 2, so 10.2 megadot. Then you got 24, and I'll cross these out as we go here. 20 down to 4 is here. 37, 30 down to 7 is around here. 40, 11 brings you around here. Notice I'm crossing them out as I go so I don't get confused. 50, 13 here. 60, 16. 70, 17. Everybody noticing a pattern out there? 70, 17. And whoa, we jump back up. 80 is only a 10. And 90 is a 0. And they did that one for you as well. So connect it up nicey nice. And hopefully you have a grid that looks something like that. All right. So we did A. We did B. Let's see what else it wants us to do. Using the map, explain why the depth of the water 20 feet from point A is different from the depth of the water 20 feet from point B. So why is, let's see, 20 feet from B is here. Why is this so much different than that? Right? They're the same distance from the shore. Well, let's take a look at what's going on. Why would it be so much deeper over there? And son of a gun, what do you know? It's on the what side of the meander, folks? The outside. And the water would be going much faster, so you would have a much, much quicker rate of erosion. Whereas at A, it's going slower, so the water would literally follow my river flow here. It would slam into this bank, circle around. Then it would slam into B and circle around. So you're going to get a lot more erosion here and a lot more deposition there. Okay? All right, and that's what's going on with the second one there. For the last one, it says the sediments being carried by the stream include clay, pebbles, sand, and silt. List them in order of deposition from C to D. Well, let's check out C to D. That's here to here. All right, well, the river's coming down from the mountains fast, and then it slams into the lake. It literally slams into that water, and it slows down. So you're going to deposit the bigger things first, and it'll go slower, 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 and deposit smaller, smaller, smaller things. So your list would have to go big to small. All right? Well, what is the biggest one here? Is it clay, pebbles, sand, or silt? Well, you probably memorized that by now, but you don't have to. You can certainly go back to the chart. The chart, of course, I'm talking about has your particle size in it, and that is right here. And there you have it, right? Pebbles, sand, silt, clay, that's decreasing in size. So go back to the problem, and the biggest thing to come out first, of course, would be your pebbles, followed by sand, silt, and the clay. All right? So hopefully that one made sense to you. Let's keep moving on down to task B here. Describe the most likely shape of the cross-section. Shape, we're talking glaciers here of the valley. So again, got to be your classic U shape. Right? Second one, after the glacier melts, what evidence would be left behind? It's asking about. Well, you'd have the U-shaped valley, of course, but the ice also scratches out the rock below, so you'll have scratches, and the rocks are going to be all unsorted, right? It wasn't pushed by water or wind, it was just bulldozed. So they would be all scratches and unsorted sediments. All right. The third one there, the range that was found at location A was, holy cow, 0.0004 to 0.006 centimeters. Identify the name of this sediment. Again, go back to that size chart, find your range, you'll find that sediment. And if you look carefully, there it is, right? It's in between those two numbers, so you're talking about silt. All right? That's what's going on right there. Over here it says the arrangement of drumlins. Drumlins are a glacial feature, right? Hills of unsorted sediment. And if you look, ice is going to come from the north where it's colder. So that's where the drumlins take on that same pattern there. All right? It wants to know which compass direction, did it advance from? Well, it must have come from the north and headed toward the south. All right, if you want to be technical, it looks like it went toward the southeast. All right. Then we go to number 5. Wants you to figure out where each of these samples will be. Well, this is all unsorted. This is sorted and all small. This is sorted and all medium. And if you remember on the North Shore of Long Island, that's kind of where the glacier stopped advancing. So it dumped all the random big stuff up here. And then as the ice melted, it would have pulled the smaller and smaller sediments down toward the south there, downhill. So we're going to put the most unsorted up top, right? So that would be Y up top. And the smallest at the bottom. And of course that puts Z in the middle there, right? That middle size. And again, that's why when you go to Jones Beach, you have such nice fine sand, because all of that was pushed downhill by the flowing water that melted from the ice. And if you go to the North Shore beaches, they're gorgeous, but you're not laying out a beach towel so much because it's very rocky. It's all unsorted, large sediments. Okay? All right. Task C, I drew the river in. I apologize, it wasn't that clear on the sheet. It was supposed to look nice and clear like this one here. So again, I apologize, it didn't come out that clear. So I've drawn it in, and if you could do so, that would be great. Right there it is, right there. Okay. All right, looks like a big topographic map from the first unit. In this region of the river, the land area is lower in elevation than 450 feet is a floodplain. Okay, that means it's near the river. Probably don't want to buy a house in a floodplain, folks. Wants you to draw in the area to indicate the entire floodplain. Well, that's 450 and below. Look at the interval of the map. The interval is 50 feet. So every line changes by 50 feet. I'm going to shade in the floodplain here. So it looks like 450 would go from here to here, like so. And once again, I would not recommend buying a house in a floodplain region. Okay, that would definitely be a bad place to buy a house. Okay, then it says describe how the contour lines indicate the river flows from A to B. How do we know it goes from A to B? I'm going to switch to the other map for a second just to get rid of all my scribblings here. But if you look, the river is here, and one of the contour lines is bending when it crosses that river. And they always bend uphill, and of course water flows downhill. So it's got to be going from A to B, because the contour line bends when it crosses the river, and it bends uphill, and water flows downhill. Okay? The third one there, why is erosion of the stream more likely at point A than B? Again, I'm going to refer to the cleaner map here. Look at that. You got a meander and a half right there, so that's the outside curve, right? Outside means faster erosion. Faster river, more erosion, and the inside is slower, more deposition. So that's what's going on there. A is on the outside of the meander, and B is on the inside. Okay. Fourth one, identify one emergency preparedness that a person can do living in a floodplain area to protect themselves. So now they've already bought the house there. What can they do to protect themselves? A lot of people try to build their house up. They'll try to elevate it a bit. If that's an option, that's one thing you could try to do. The next, of course, make sure you're tuned into the forecast, right? When it rains, the rivers are going to get more water, greater discharge, and you're going to get more flooding. So if you do hear a rainy forecast, get your car and your valuables to higher ground, right? That would be a very smart thing to do. The last one here, after a thunderstorm, the velocity was 100 centimeters a second. What is the largest type of sediment transported? Well, 100 centimeters a second, you know where to go, I hope. Back to your chart. 100 centimeters a second is on the bottom here. Go up. Anything underneath the black line gets eroded. And the biggest thing getting eroded here are the pretty big pebbles, and of course everything else. But it wants the biggest one, so that would be your big pebbles. Okay, and that took care of that one. For your last one here, it wants you to interpret the landscapes. Which drainage pattern would this happen? So if it rains here, what path would the water take? Well, it looks like you have these lower areas that are linear, right? The water's going to go in those areas. So you're looking for one that's got kind of a linear drainage pattern. Well, that's circular, that's out. This is all random, right? These two are both kind of random, but if you look closely, these are kind of linear and it matches the shape here. So that's what's going on right there. They call it a trellis pattern. So we're going with choice 2, right? Because it has that trellis linear pattern. The second one there, those are T's, by the way. The cross section to the right, asking you what's what. So what kind of landscape is this, this, and this? Well, this is a high elevation with horizontal structure. That's a plateau. This is a low elevation, got to be your plain. And of course, this is uplifted and all distorted, right? That's your mountainous regions. All right, so A, of course, is your plateau. B is your plains. And C is the mountainous region. Okay. The watershed map to the right shows 4 watersheds. Which one represents the Mohawk and the Hudson River? Well, there is no way you're going to memorize that. Hudson and the Mohawk, you got to go back to your New York State map. And that, of course, would be right here. Let me rotate that. You're looking for the Hudson and the Mohawk rivers. And if you zoom in, all right, you can see there's your Hudson and here's your Mohawk. So which one would that be on this map? Well, clearly it would be area C, right? The fourth one, in New York State, identify the surface bedrocks of the Catskills Plateau. Well, again, you got to go back to your reference tables, find the Catskills, what type of rock is it? So, here I am, I'm going to the Catskills, which is right here. Now go to the map below, zoom in on that same region. I got a lot of polka dots. Polka dots tell me it's Devonian. And of course, that's limestone, shale, sandstone. That's all sedimentary rock. Okay. So you're looking at sedimentary from the Devonian. And again, the Devonian is the age of the fish, and we'll get into that. A lot of neat evolution and fossil evidence there. Number 5, it says Old Forge and Watertown are at the same latitude, but have very different landscapes. What factors are responsible for that? Well, go back to your New York State map. Find, we're looking for Waterville and, Old Forge and Watertown. Well, take a look. Old Forge is right here, and Watertown is here. So they're at a similar latitude, but this is up in the Adirondacks, right? You can go down to your landscape map to see that. And Watertown, if you look closely, is pretty much, went the wrong way there, is pretty much at the foothills of that. It would be in your Erie, Ontario lowlands, right on the fringe of the Tug Hill Plateau. So why are they so different? Well, the mountains were uplifted from below, much higher elevation, whereas the plain and plateau area, they haven't been uplifted much, so they're at a much lower elevation. It had to do with those tectonic forces. All right. So I'll give you a hand on that one. Old Forge has been uplifted. All right, and the last one there, number 6. Which 2 locations are found in the same major landscape province? You got to do a process of elimination here. But if you went through all of them, take a look at Jamestown and Slide Mountain. Jamestown and Slide Mountain are all in this same region here. And you're probably starting to recognize it now, right? That is your Allegheny Plateau. And you can see that right here. Jamestown would be here and Slide Mountain over here. So they're both in the Allegheny Plateau. All right. Hope that cleared up any confusions you might have had. If you still have some questions, obviously leave them down in the comment section or shoot me a question on Remind. All right. Make sure it's submitted with your complete Tic Tac Toe, and look for the assessment that will be posted momentarily. And I'll give you 2 days to crank that out. All right. All right, folks. See you soon.